Okay, good afternoon. Today I'm going to look at vertical exaggeration, which is one of the map calculations in FET geography. So the first thing that I'm going to do first is to start by defining the concept that I've related to the concept of vertical exaggeration. So the first thing that we're going to do, we're going to look at the definition of vertical exaggeration, what it is. We are also going to define cross-section. We are also going to define intervisibility. So these three concepts, they make hand in glove. Whenever you are asked to calculate your vertical exaggeration, obviously you also consider cross-section. Obviously, you also consider maybe the definition of which we are going to say it right now, and also the aspect of intervisibility can also be assessed in relation to the concept of vertical exaggeration. So from what I've written down, I think we can see that our vertical exaggeration is the degree to which vertical scale is larger than horizontal scale. The degree to which the vertical scale is larger than the horizontal scale. So whenever we talk about vertical exaggeration, obviously we cannot talk about vertical exaggeration without considering our vertical and horizontal scale. I'll move to a stage where I'm going to demonstrate what our vertical scale is and also what our horizontal scale. But in most cases, our horizontal scale becomes the scale that is shown on the map. If it's on the topographical map, which means we're going to use 1:50,000. If it's on the orthophoto map, we're going to use 1:10,000. So it's the relationship or the degree to which vertical scale is larger than the horizontal scale. Then the concept of cross-section, a representation of a rise and fall of a landscape along a given line. You are given the landscape between 2 points, of which there can be rise and falling of the landscape as you navigate it from one point to another. So basically, when you're looking at the cross-section, it's more like a side view. That is the representation of the side of the rise and fall of the landscape along a given line. So the most important thing that you have to take cognizance of is a representation of the rise and fall of a landscape along a given line, which means the assumption is we are looking at 2 points from A to B. So along that landscape, there is rise and fall, which means we have highland, we also have lowland along the same cross-section. So it's a representation of that rise and fall of a landscape along a given line. Then for the concept of what we call intervisibility, when the line of vision between 2 points is not obscured by any given obstacle. Like for example, let me take A and B. Then let's assume that between these 2 points A and B, there is a rise in terms of landscape. One cannot see B from A. It means between these 2 points A and B, there is no intervisibility. You cannot see B from A. That's why we define it as when the line of vision between the 2 points is not obscured by any obstacle. So when it's like this, it means there is no intervisibility. But when we are able to see from A to B, then we say there is intervisibility because we're able to see from point A to point B. So the next thing that I'm going to do now, I'm going to demonstrate how you can actually calculate your vertical exaggeration. Number one, how you can also do your cross-section, and also how you can analyze the intervisibility between two given points. I'm going to draw a landscape. And then I'll also indicate the landscape from A to B that I'm going to use as an illustration in the calculation of our vertical exaggeration. Okay. We'll use this as our river, and I'll use this as well. This one, I'm going to mark it as 300, this one 250, 200, 150. I'm going to have 100 here. I'm going to have 100, 150, 200. I'm also going to have, okay, 250 and 300. I'm going to indicate from A to B. So here what's what I'm going to do. Remember, we have defined the concept of vertical exaggeration. We have also defined what the cross-section is, and we also defined what intervisibility is. So we are going to do a cross-section from A to B. You can see from A to B in terms of our landscape. This is 300 meters, 250 meters. We have 200 meters, 150, 100 meters. Then in between, we have a river. Then from the river, we have 100 meters, 150, 200, 250, and 300. Remember, when we're talking about the cross-section, we say that this is a representation of the rise and fall of a landscape. Which means if you look here, you'll see that this is where we have got the higher land, which is 300 meters. But if you look close to the river here, you can see that it's lower. You can see here is 100 meters, there as well is 100 meters, which means as you go towards the river, you can see that the height is decreasing. And also as you move away from the river going upwards, you can see that also the height in terms of potential height is what is increasing. So what we're going to do first is we are going to do a cross-section of A to B. Remember, we said that this is a representation of the rise or fall of a landscape between two given points. So these are the given points, that is your A and B. I'm also going to assume that the map that I'm going to use is a topographical map. So I'll have my 1:50,000. I think you are aware of what is the scale of a topographical map. So I'm going to use the scale of a topographical map is my horizontal scale. So here's how I'm going to do it now. So I have to come up now with how I can actually record, or how I can actually mark on this height from point A to point D. How do I go about it? So the first thing that I'll do is I'll need a paper, one like this. I'll need a paper like this. Then I'm going to mark my height from point A to point B. So here I've got 300. Then I've got 250. I'm going to try to make them as close as possible. I've got 200. Then I've got 150. Then I've got 100. Then in between, there's a river here. Okay. I'll just do it like this. Okay. There's a river here. Then I go again to 100. Then I go again to 150, 200. 250, then I go to 300. So what I've done is I have tried to align my different heights in terms of, okay, different contour height from A to B across, more like a side view. Remember, we said the representation of the rise and fall of a landscape from one position to given point to another. This is my one given point A to B. And from that, what have I done? I have marked my contour height, okay, which shows the rise and fall of the landscape from A to B. I try to make it as compact as possible so that I can be able to accommodate from here up to there. So the next thing that I'll do is I have to come up with my vertical scale. How do I go about it? I'm going to demonstrate using this, okay? This is going to be my vertical scale. So if I look at the contour interval, which is the height difference in height between two contours, 50, 300, 250 is 50. So I'm going to use my vertical scale of 1 centimeter to represent 50 meters. That is what is going to be my vertical scale. VS is equal to 1:50 meters. This is what I'm going to use as my vertical scale. And I'm going to use this as my horizontal scale. So the next thing that I'm going to do now, I want to plot my cross-section from A to B. So what I'm going to do is I'm going to, okay, is 100, then from 100, 150, 150, 200, 250, 300. One thing that you have to make sure is your scale. especially when looking at the vertical scale in terms of the size, it's supposed to be the same as it goes upwards. Then I have got this that I have marked. Remember, I was just marking my height, my contour height from point A to B, which is given so that I come up with my cross section. So I'll get my paper as it is. I'll come here at the bottom so that I can also be able to mark. Okay, so I'll have my 300 here. I'll have my 250. This is how it's aligned. Then from there, I'll have my 200. Then I'll have my 150. Then I'll have my 100. Then, of course, here's where the river is. I'll have my 100 here. I'll have my 150. I'll have my 200. I'll have my 250. Then I'll have my 300. So now that I have marked this on my, this is where I'm going to show, this is A, this is B. So to make my life easier, I'm going to do it this way. I'm just going to, of course, I'm not going to use a ruler, okay? Just going to try and make sure this is where my 50, this is where my 100 is, this is where my 200, my 250, my 300. So this is my vertical scale. You can see from 0, 50, 100, 150, 200, 250, and 300, which is my vertical scale is 1 centimeter to 50 meters. Okay, then my horizontal scale that I'm going to use, the one of a topographical map, which is 1 to 50,000. So I'm going to start plotting now my cross section from A to B. So the first thing that I'm going to do is I'm going to mark where my 300 is, which means I'm going to mark it here. Okay, then the second thing, given that I have a ruler, just to make it straight, I'm going to mark my 250, which means my 250 is going to be here. This is where it's meeting. Then my 200, I'm going to do, okay, my 200 is going to meet here. Then my 150 is going to meet here. Then my 100 is going to be here. Then where's my 100 again? My 100, which means I'm going to get it here. My 100 here. My 150 going upwards. I'll have my 150 here. My 200. Where's my 200? Here. My 250. I'm going to have it here. Then I'll have my 300 here. So this is how my cross section is going to look like. Starting from here, I'm connecting now. Then here, I'm going to show that there is a river. I'm going to show that there is a river. I'm just going to show it like this. I'll just say R here. Then I go upwards until I reach there. So what I'm going to do now is I was using this to help me to plot my cross section from A to B. So I'm just going to rub it off nicely. I'm going to erase it. I'm going to erase it. Okay. I'm going to erase it nicely. Okay. So, as you can see, this is, let me put my B here so that at least this is where my B is. So, as you can see, the cross section now, this is where my river is. Okay. This is where my river is. Let me just make sure that is a valley. This is my cross section from A to B. You can see, we said that this is a representation of the rise and fall of the landscape between two given points, which is from A to B. I plotted here my cross section using this graph. Of course, I've got my A and my B. This is my vertical scale, and this is my, this is where I plotted the different contour heights. So this is my cross section from A to B. So first thing that you do, know how to plot a cross section. This is the cross section. Of course, it is going to have a title, a cross section from A to B. All right. This is a cross section title. Of course, we are supposed to have a title, a cross section, cross section from point A to B. Obviously, whenever you're doing a cross section, you're supposed to make sure that you put a title. So this is your cross section. So the next thing that we also talked about was intervisibility. We are saying now, are you able to see from point 1 to point 2? So when we talk about intervisibility, we are saying that there is no obstruction between two given points. Assuming that you are standing at A here and B is here, will you be able to see B? Yes. You will be able to see B, which means there's intervisibility. It means you are able to see B from A. You are able to see B from A. Same applies. If there is C here, okay, there is C here, C to B. Will you be able to see B from C? Yes, you will be able to do. It means there is intervisibility. That's what it's all about. If there are obstructions now, if it happens that maybe I've got my D sum here and C is here, you won't be able to see D from C, which means there is no intervisibility. So intervisibility simply means that there is no obstruction between two given points. You can see clearly. That's what it's all about. So that is it in as far as the concept of intervisibility is concerned. So from A to B, we can see B, this is your A, this is B. So you can clearly see B. There is intervisibility between A and B. I'm going to rub off this, then calculate vertical exaggeration. I'm going to rub off this, then I'll calculate vertical exaggeration. Or I can just calculate it by the side. Okay. So when you're calculating your vertical exaggeration, I'm just going to abbreviate it as VE. This is how you calculate your vertical exaggeration. You say vertical exaggeration is equal to your vertical scale divided by horizontal scale. Why are we exaggerating the scale? You see that when you're looking on a map, you might find that some of the features, when you're looking on a map, like let me use this, can you come up closer? When I'm looking at a map, let me use this as an example. You will find that some of these features might not be that visible. They might not be that visible. So that's why we exaggerate the scale, so that we make sure that these features from two given points becomes more visible. That's why we use the vertical exaggeration. You can see from the map that some of the features that are on that map cannot be that visible if we are going to use that, the normal scale that we have. But we try by all means to enlarge it. That's why we're using the vertical exaggeration. So now the formula is how you calculate your vertical exaggeration. We say vertical scale over horizontal scale, which means if I'm going to look at my vertical scale, remember this is my vertical scale, okay? 1:50, which means 1:50 meters divided by what is my horizontal scale. Remember I said my horizontal scale, I'm going to use what? The map of the horizontal is the scale of a topographical map. This is in centimeters, remember? This is in centimeters. So I'm going to convert this into meters to make my life easier. So if I'm to convert 1:50,000 into meters, I'll get 1:500 meters. How did I get that? How many centimeters are in a meter? It's 100, which means I've just divided by 100, then I get 500 meters. That's what I've done. So it means here it will be 1/500 what? Meters. Because I have to make sure that the units are the same. This is in centimeters. This one already, our contour lines height is in meters. I have to make sure that I convert now my scale of the topographical into meters as well. So it's going to be 1/50 meters divided by 1/500 meters. So what I'm going to do, I'm going to invert it, okay? 1/50, then I'll say multiplied by 500/1, okay? I'm calculating my vertical exaggeration. So what I'm going to do, okay, 0, 5 here, 1, 5 into 15 times, which means my answer now is our vertical exaggeration is 10 times, which means our vertical scale has been exaggerated 10 times. That's what it simply means. So we are looking at the relationship between our vertical scale and horizontal scale. Just to sum it up, so whenever you talk about vertical exaggeration, obviously we are looking at the degree between our vertical scale and our horizontal scale. So what we are simply doing is whenever you are calculating your vertical exaggeration, what you have to know is it actually intertwined with the concept of cross-section and the concept of intervisibility. So the first thing that you need to know is you can be asked or you can be assessed on how to do a cross-section. This is how you do your cross-section. I think I've explained it in detail if you can go earlier to this video. This was our area from point A to point B. These are the marked contour heights you can see now it's now represented as a cross section where we have got our vertical scale 0.50 going upwards. We have also used this paper that we have used to mark the height from point A to point B, and we have plotted the heights, contour heights from point A to point B, which is 300 up when it gets there. Then when you're looking now at your A, you've got your A and you've got your B, which means this is now your cross section from A to B. Then from there, I've talked about intervisibility. Are you able to see one point from another without any obstruction along the line of vision? Here you can see A from B, which means there's intervisibility. You are able to see, you can clearly see there are no obstruction. Then from there, the last part, which is our calculation, is vertical exaggeration, which is your vertical scale divided by horizontal scale. We have got our vertical scale as to 1:50 meters. Then we have got our horizontal scale, which is what we have on our topographical map. 1:50,000 centimeters. This is supposed to have the same units, so we have converted it to meters, which becomes what? 500. Why? Because 1 meter is equivalent to 100 centimeters. We have divided by 100. So we have got 150 divided by 1/500 meters. So this is what we have first. This is what we have first. Okay. This is your horizontal scale, your vertical scale, your vertical scale, your horizontal. You can see the division line, okay, symbol. Then from there, 1/50 meters multiplied by 500 meters over 1. I've inverted, okay? So our vertical exaggeration is 10 times, which means our vertical scale is being exaggerated 10 times. This is how you calculate your vertical exaggeration. Ta-da!